Okay, so in the last class there was a very nice question which I had to look into more detail about that in order to solve that questions. Okay, so first let's understand the question what it is. Properly the question should say like this. So that was there was inclined plane at an angle of alpha, and there is a point, there is a bead. This bead is being dropped from some height h on this inclined plane. So this height is h. From this height it is being dropped. Okay, so let me keep this earphone here because it got completely discharged. Maybe it will charge for some time and then I will put it again. Okay, so this is the question is that there is a uh, there is a inclined plane, and on this inclined plane from a height h a bead is dropped. Okay, and that bead has to reach here. But how the bead is dropped? They are saying that bead is released in a wire, and they just told that wire can have any shape. They did not mention clearly. But when I look into the answer, how to get that answer, the I need to make assumption that the wire is a straight wire. That means from this we are releasing the bead on a wire. Then wire can be of only straight line shapes like this in any direction it is. Okay, any direction. Of course it cannot be up because it will not go up. You have to release on the wire and it will slide in the wire and it will hit the inclined plane. That is the idea. The bead will slide in the wire. The wire has straight line shape. That they didn't mention in the question clearly. Okay, that is why we started thinking in a different manner. But now, while we thought like that, that has become a very good question actually. It has become a question of international Olympiad level. But this question is not that much high level if you consider that bead is sliding in a straight wire only. Then that is not such a international Olympiad level question. But if you take that wires can be taken any shape, then it becomes a Brachistochrone curve that we will discuss afterward. Okay, that is called Brachistochrone curve. Okay, that it is a quite complex question. But let us first discuss about this. So bead is released from that point and it is connected through straight wires. These are straight wires in all direction. Straight straight wire in all possible direction, in all possible direction. And what is the question is that the bead should take minimum time to hit the inclined plane. Bead should reach the inclined plane in minimum time. That is the question. And what is that minimum time? We have to calculate that. Okay, we have to calculate that minimum time. Are you clear about the question? Yes. Okay, so let us now take the bead and release it at any plane. Like let us consider that there is a wire in this bead is going to move. Bead is going to move in this wire. Bead is moving in this wire. Okay, right. So, but you need to define the, because any straight line has some slope or something direction will be there, right? So this straight line you need to define something related to that. How do we define? Let us define this is making an angle of um, with the horizontal. Let us say that this line is making some angle theta with the horizontal. So theta is a variable here. So if you keep different angle, you will get different lines, right? Keep different angle, you will get different lines. So this is representing a wire. Okay. Now beads is released, but what we know is that at a height h below there is a at a height h below, and this angle at which this inclined surface is there, this angle is a fixed angle. This angle is alpha. Okay, this angle is alpha. We know that. So it will be coming here in some times. The question is that when it will come here. That the thing. So if I consider this distance as h, This distance is h I have taken. This angle is alpha. So try to think more about this. This is h, and this is definitely going to be 90 degree because this is vertical and this is horizontal, right? Vertical and horizontal. This is alpha I have taken, so this is also angle alpha only. Right. So can we calculate this length? Because if you calculate this length, if we calculate this length, we can think of acceleration in this direction. Because acceleration in this direction we can calculate, because this is making angle theta with the horizontal. So acceleration is always acting g in this way. So in this direction, how much angle it will act? Because this line, if this line is making angle theta with the horizontal, this is like also another inclined plane, you can say. So in this direction, we can resolve g. Let us resolve. So this is theta, this is 90 minus theta, so this is theta. This direction component of g is g sine theta. This direction component is g cos theta. Okay. So the component of g, when the bead is sliding in this direction, let us say bead is going to slide in this direction. So the component of g, acceleration due to gravity, in that direction is g sine theta. Okay, that direction acceleration component is in, but theta is variable. We should note that theta is variable. Hmm? Okay. Also note that if this height is h, this is alpha, so this is 90 minus alpha. This is anyway, we do not know what is this, but definitely this will be 90 minus alpha. That will be 90 minus alpha. I want to calculate this length. I am interested to calculate this length. Can we calculate this length? What do you think? This is definitely 90 minus alpha. Can we calculate this length? I am interested to calculate this length. This length, note that this is not perpendicular, okay? This is making angle theta with the horizontal. So can you find out this length? Because if I find this length, I can calculate time. Suppose this length is L. So then time is equal to root under 2 length by acceleration in this direction will be g sine theta. I will get this. If I can get length, in terms of h and theta or alpha, then I can differentiate this, because time I want minimum. So let us try to calculate length. Okay, length you try to calculate. Do something to calculate the length. Tell me how to calculate. Any ideas? Yes. Huh? What? No, no, that is the only data given. Given is only h is given and alpha is given. Only h and alpha is given. Theta we are assuming as variable. So can you what? H is not maximum. Whatever h is it, h is given. Just a constant value it is. Is released from this height. L we have to bring it. Try geometry. Can you apply some geometry to calculate L? Again, I will draw this geometry. Okay. I will draw this geometry. So this distance and this distance are perpendicular. This is a inclined length. It may be any length, and this line can be going in any direction. Let us take like this. It may look little bit better. Should not get confused. So this angle is theta I have chosen. This angle is going to be alpha, right? Because this angle is alpha. I want this length. This length is h. This length. So I can say that this length is how much? This length will be 90 minus theta. This will be 90 minus theta. This length is 90 minus alpha. Can you guess how much will be this angle? This angle or this side angle? Yeah, this is theta, this is alpha. This is like exterior angle, so this become alpha plus theta. Yes, are you getting this? Yes. Okay, now it is very nice to think about the sine law. Sine rule you need to apply now in this triangle. We are getting a triangle whose this angle is 90 minus alpha. This angle is 90 minus theta. This angle is alpha plus theta, and this length is L, this length is H. We don't have any idea of that length, but it's not a worry. We can just let us say this length is Y or anything it is, okay. So we can take these sine ratios. Sine ratios is what? Sine and side opposite of sine. So suppose if I take H, opposite of H is alpha plus theta, so sine of alpha plus theta. Then I will take this as L. L opposite of L is sine 90 minus alpha, and opposite of y, this angle is sine 90 minus theta. So this definitely I can get one idea. But we want to find L in terms of known things. So now I will use this only. These two equation only I will use. I don't use y. Okay, so I can calculate L now. L, let us calculate. So L will be H into sine 90 minus alpha become cos alpha divided by sine alpha plus theta. Yes. So now I will substitute it here. So time formula will become root under 2 times length. Length is H cos alpha divided by sine alpha plus theta. Right. L I substituted and G sin theta is also multiplied here. Correct. So now what do we want? Let us write this time again as root under 2h by g. I will separate. 2h by g. Constant also I will separate. So 2h cos alpha by g I separate. So what is remaining then? Remaining is sin alpha plus theta into g sin theta. Correct. So I will separate this separately. Separate it. So sin theta into sin alpha plus theta. Yes. Clear? I have separated it because these are constant values. H is constant, alpha is constant, this is constant. Variable is alpha, theta and theta term. These are variable I separated. Now I want minimum time. This anyway constant. So if I want minimum time, I should take minimum of this expression 1 by this. This I want minimum. And if I want minimum this, that means this denominator should be maximum, or inside the root should be maximum, because if this is maximum, this everything will become minimum. So let me define a quantity here as, let us call it as z. This term I am going to write as z. What is that? Sin theta into sin alpha plus theta I am taking as z. So this z I want maximum. I want this as maximum. So anyway, to get maximum minimum, you have to differentiate. So let us differentiate z. I think somebody is, yes, Sahil, any question in this? Yeah, that is the same way. Same thing it is. No, you can just take root also, but if inside the root is maximum, then this is also maximum, right? So that's why better to simplify the calculation, take inside the root, because you want this as maximum, correct? This term, this is a constant now. Why you want to differentiate it? It's a constant, right? So whatever is variable, that only we will differentiate, and we will find out at what value of theta this happens maximum. Okay, let us try to differentiate this. So dz by d theta, let us do that. So these are two terms, so we will use product rule. So leave sine theta, differentiate sine of alpha plus theta with respect to theta, plus leave sine alpha plus theta, differentiate sine theta with respect to theta. Apply this differentiation and try to do something. So sine theta, this I am going to use chain rule. So sine of this with respect to this, and then sine of this with respect to theta, because this is chain rule. Okay, I am writing chain rule here. chain rule. Here, this is sine alpha plus theta, and differentiation sine will become cos theta, that we know. This one chain rule I have to apply, and this is 0, we have to take this 0. So sine theta, sine of this differentiation will become cos of this, and then alpha plus theta, when you differentiate, alpha is a constant, differentiation 0, theta with theta differentiation is 1. Okay, differentiation we are doing, then here it will become sine alpha plus theta into cos theta. Okay, let us do that. So this is becoming sine, this is anyway becoming 1. I think this is sine, I think some formula is coming, just see, sine theta cos theta cos alpha plus theta plus cos theta sine alpha plus theta, something is coming here, sine a cos b plus cos a sine b, what it is? Yes, so this is like sine a plus b, let us do that. Okay, so a theta plus, so this is going to give us sine of alpha plus 2 theta, it will give, correct? Okay, so we have got some result from here. So sine of alpha plus 2 theta is coming like this. So what can we take this value of angle? Can we take 0? There are many possible values, or many possible values can happen. It can be 0, it can be pi, it can be 2 pi, it can be 3 pi, because sine is 0 at all these possible values. Yes. Okay. What? 1 minute, 1 minute. Not able to hear. Let me 1 minute. I will try to connect earphone, because my laptop is also making some noise. That's why I cannot hear. Okay. Yes, I'll tell. Yes. No, we can take all possibilities. That's what I'm saying. Hmm. What? Huh. This one, Ahil? Yeah, that is what we started with this idea. Now, what was the idea? We want Z maximum, or maximum minima differentiation is 0, na? That is the main idea. Correct, na? Any function you want maxima or minima, the slope is 0, dy by dx is 0 for that, right? Okay, so this, what negative positive? Okay, you are saying double differentiation. That we'll see afterwards. Now, why to make complex things right now? First, somehow we have to calculate single differentiation, right? Double differentiation, of course. See, when you want inside, now you don't want negative of this, because inside the root only positive will come. So somehow we have to get the values of that such that it should come positive, and then we will see that. Okay. We can check also double differentiation, but after calculating the values of this, then only we can do. That will be next step. If you want, you can make sure by double differentiation. But we will not go, because it will be unnecessarily lengthy, because we have to make sure inside root will be positive only. Okay. Okay, so here many values are possible, right? Many values are possible answers, alpha plus 2 theta. But we want z to be positive. So what should we take z? Z we want a positive value. Sin theta, sin alpha plus theta. Let us come back to that. So we have z as sin theta into sin alpha plus theta, or theta plus alpha. We have this one, right? So, so how do we get some values based on this root? So if I try to take, for example, suppose if I take alpha plus 2 theta 0 here, then what do we get from here? I should try to eliminate theta then. Suppose in general I will write it as n pi. Okay, in general I will write, because n is an integer and pi is just pi. So n is 0, 0 pi, n is 1, 1 pi, n is 2, 2 pi, like that I'll keep. So I want to eliminate theta here. I want to put the value of theta here. How should I put it? Okay, let us take 2 theta here, because alpha is constant. So I will put in terms of alpha. Okay, sine of 2 theta. So one thing is, okay, let us try that. So put theta here now. So theta is going to be n pi minus alpha by 2. It will be, isn't it? It will be like this. So let us put this theta here. N pi minus alpha by 2 it is. Okay. Uh, okay. Then this will be sine of theta plus alpha. What will be theta plus alpha? Let us also put that. So theta is n pi minus alpha by 2 plus alpha. Okay, try to simplify this. So z is equal to sine of, I will open this separately as n times pi by 2 minus alpha by 2. Okay, like this I'll break it, and this I will take also, I'll break it, n pi by 2 minus alpha by 2 plus alpha will become plus alpha by 2. Okay, like this will become. So now suppose if I take as n as 1, okay, I will not commit any crime if I take n as 1, right? We can take 0 also, but if you take 0 you will get negative values. Okay, so better you take n as 1 to get some good answers, because you want this z to be positive. Okay, so let us choose n as 1. Choose n as 1. So if I choose n as 1, sine will be pi by 2 minus alpha by 2. Pi by 2 means 90 degree it is. Okay, and sine pi by 2 plus alpha by 2. So sine 90 minus theta is cos theta, so this will become cos alpha by 2. And sine 90 plus theta is also cos. This is also cos. That means cos square becomes, yes. So that looks to be something better. Okay, I think we got this z value. At this z value only we will get answer. Okay, this is what it is. Now let us substitute in the formula, in that z where we have put it, in this root under 2h cos alpha by g. Let us substitute that. Inside root z will be there. So time formula which we have, root under 2h by g, and here it was 1 by root z, because that term I have taken z. Now I will substitute here z. So, and I think here inside cos alpha was also there, right? If I am not wrong. 2h cos alpha was there. 2h cos alpha by g and root z was there. Okay. 2h cos alpha by g and root z was there. 2h cos alpha by g root z. Yes. So z root z we have got cos square alpha by 2. So root z will become cos alpha. Yes, cos alpha by 2. Yes. Let us substitute this. So we will get this as root under 2h cos alpha by g is 1 by cos alpha by 2. So secant will come. So t will come as secant alpha by 2 root under 2h cos alpha by g. Let me match again the answer, whether I have got the correct answer or not. Let me match it. This question was motion. Yes, this is the right answer. we have got the we have got the right answer. This is the answer. So this question is a good. This question itself is a good level of question. Okay. So here we have to do this much calculation. But in this question it was not given clearly whether we should take wire as a straight or not. That is why I was thinking wire to be a curved wire also. Okay, because in the question they should mention it now. If they mention it, then I will think it like this way, then I could have solved that itself. But that was not clear. Now I have started thinking the wire to be a curved wire, because I started thinking wire, so I got a very different idea about that. That idea is called Brachistochrone curve. I will explain that. This answer is over. This question is over. Now, a next type of question that can come from this is same question. You think about this. This bead is being dropped from a height h. But now the wire can take any shape. Any shape it can take. It is free to choose. You are free to choose any shape of the wire. Now, this question is definitely a question of international Olympiad. Okay, so here what shape the wire will take so that time will be minimum. So that shape is called Brachistochrone curve. Okay, that is called Brachistochrone curve. Okay, Brachistochrone curve. So that is going to take very small time, minimum time. Okay, Brachistochrone curve. So that has been a problem in the history of physics. About, there was a story related to that. There is a scientist whose name is this Newton. At the time of Newton, this Bernoulli's theorem you have studied, Sam. I think Bernoulli's principle you have studied. So Bernoulli, his name was I think Johann Bernoulli, yes. So that person was working out some questions. So history related to this is like that. That suppose, in these slides that they make for kids, slides, right? They make slides for the kids in the garden. So they want to find a path. They want to find a path so that if any object is released, it will come here in the minimum time it will take. Okay, time will be minimum. And a very important feature of this Brachistochrone curve is if you release from here or anywhere you release, this time will be the same minimum time, whether you release from top or mid or anywhere, it will take the same minimum time to reach the bottom. That's a very important feature of Brachistochrone curve. Okay. So we can solve this, of course, but I am not going into detail of this. There is a way to solve it. Afterwards, we can think about it. But Brachistochrone curve is a curve in which when you release anywhere you release from this path, it will reach to the bottom in the same time. Same time. It looks very imagine how it reaches. Okay. So even if you take from top to bottom also, let us say you study from top to bottom, it releases in minimum time. You draw any path. Suppose you draw a straight line path, you draw various curve you draw. Okay, so it must reach in the same time, and that time must be minimum. So if you compare different paths, Brachistochrone curve is the answer for that. Okay, so if you take different paths, straight line, parabola, hyperbola, Brachistochrone curve is called a cycloid curve. Okay, so this is called cycloid. So cycloid curve is the answer for this minimum time. Okay, and then that we can do it, of course. Afterwards we will do that. Right now we will not go into more detail of this. It can be done, but then it will become totally very difficult level things. Okay, right? But if no, this thing what I am telling now, that this story is about that Johann Bernoulli. So when he had this question, he solved that question first himself, because he was a great mathematician at that time. So he solved that, and then he challenged many scientists, including all the big physicist people. They sent letters, open letter challenge they gave, but nobody accepted. Many people tried. Galileo also tried. That time Galileo also gave some answer. So Galileo tell that this will be a circular arc. He told that it will be a circular arc, but his answer was not accurate, but it was almost reaching to the exact answer. It was like an approximate result. So Galileo's was like he got somehow he got that idea that it should be a circular path, and he gave that, and for centuries they were following this idea that circular path will be taking minimum time. But then many people started challenging, and then when Bernoulli is taken this idea, then he solved mathematically. Bernoulli solved it. Then he challenged everybody, including Newton. So Newton was very old at that time, but Newton was a genius. Newton was a genius, and he solved it, and he solved it, and he write that letter without his name. He sent it to Bernoulli. So Bernoulli could understand this is only Newton can do it. Nobody else can do it. Okay, so he did it, and then he found it, those equations, and that thing he got it. Okay, that's a very interesting thing. But it's possible to understand this idea if you have studied spring mass system. Why I am telling it like this? Because recently I got to learn about this idea of Brachistochrone curve. So suppose if you take spring mass system, spring mass system, if you take, let us say this is block of this, and let us say, and suppose you disturb it, you know what is the time period of this? What is the time period? All of you know, means good 12th student, definitely they will be knowing time period. Omega is equal to root under k by m. So time period is 2 pi root under m by k. K is called spring constant. Okay, is called spring. So time period of this is independent of how much you release, how much you compress. It doesn't matter. So same thing is happening here in Brachistochrone curve also. Brachistochrone curve, if you see here, suppose this is the length of this path of Brachistochrone. Okay, and this is the bottom point, and this is the top point. This is like extreme position. So anywhere, suppose if I release it from here, let us say if I release from here, okay, if I release here, so speed will be 0, and this is like the equilibrium position where it comes to time will be proportional to what? Time is not going to means depend on any path length. Whether you drop here, it doesn't depend on path. But let us take that this is the length of the path. Okay, so this idea is coming just like a spring, and a spring, in case of a spring, acceleration is proportional to, acceleration is equal to minus omega square into x. X is the length of that, or displacement you can say. So acceleration, magnitude of acceleration is proportional to x. You can say that this idea will be used to solve Brachistochrone curve. Okay. So here if you take the acceleration, let us say for example at this point if you draw tangent, and this tangent makes an angle some theta. Okay, so tan theta, so you know acceleration, just now we have discussed component of acceleration in this direction, that was g sine theta. Okay, g was perpendicular, g sine theta is that. So g sine theta is nothing but acceleration, and this acceleration is proportional to length. Length means this length, so proportional to this length. Okay, so g sine theta is proportional to this length. Hmm? V sine theta is proportional to this. Then let us take some constant as C1. C1 is some constant here. Okay, right. Now from here, G is a constant. C1 is also L is the length which we have taken here. Okay. Now you know this tan theta is nothing but dy by dx because it is the slope of the tangent. Tan theta is dy by dx. Okay. So somehow we need to bring some relationship, and also note that suppose you have released from somewhere, let us say you have released from the top position, because you are releasing from top position, right? You are releasing from top position. So when you release from top position, speed is 0, or you release from here, doesn't matter. You release from wherever you want to release. Okay. But when it comes to a height y height below, let us say it comes, it gains a speed based on energy conservation. It becomes root under 2gy. Okay, the speed becomes root under 2gy. That is the speed. Okay. Now we can think of getting some idea from here. V is equal to root under 2gy. and tan theta is equal to dy by dx. Some relationship we need to get, and we need to eliminate something from here. Okay, we will get some relation from there. How do we get that? It is possible to do some elimination or some calculations from here. We can do velocity is equal to root under 2gy, and dy by dx. If you want, you can differentiate it, because dy by dx can be calculated from here, right? Some calculation will come from, and then we can do some differentiation, and we can establish some relationship between them. Okay, that relationship when you yes. No, this cannot be discussed in the class. These topics are far more difficult topics. So, uh, this we cannot yes, cover in the class, because then everybody will their head will spin, right? So we cannot okay, but huh? Right now we are going to start Newton's laws of motion. Hmm. Okay, so that we will be starting it. Newton's laws of motion we are going to start next. So anyway, I will give you solution. If you want, let's continue this. If you do this like this, sine theta. How do we calculate sine theta? If you take a small length, let us say this is dy, this is dx, and this is dl. This angle will be theta only. So from here, sine theta can be written as dy by dl. Let us start to substitute here. So you will get g into dy by dl is equal to c1 into length. Okay, then you will write this as g into dy is equal to c1 ldl. Then you can integrate this. Okay, so g will come out, integration of dy will give y is equal to c1 come out, and l integration l square by 2. Some extra constant if you want you can take, but if I take 0 to 0, let us take 0 to 0, something like that I can take this. Okay, or if some constant of integration if you want you can add it, that's not a problem. Okay, so you will be getting this type of equations, right? Then what? Hmm. So yeah, we will be getting this like this. And also already we have seen that length is equal to okay, suppose if I take for example try to calculate length from here, let us take c2 as 0, because it can be any some constant. Let's take this 0. So l will be proportional to root of y from here, right? Length will become proportional to root of y. Proportionality means some constant. If you want you can assume some constant, or let us differentiate this dl. Let us calculate dl. Okay, or you can differentiate with respect to time also, but let us I differentiate this. So 1 by root is 1 by 2 root y, and this will become dy. Okay, like this it will become, right? dl, and let us now square this. So dl square will become proportional to, this will become dy whole square by 2 square will become 4, and this is some other constant. Let us keep remove the constant, so it will become y like this way. Okay, so now note that in this triangle this is dl, this is dy, this is dx. So this is like a small hypotenuse square, which will be like dx square plus dy square, right, is equal to or is proportional to, let us say, that is dy whole square by y. Okay, now try to bring one side dy square and try to write. So dx whole square will be proportional to dy whole square. I will bring one side I will bring, and this will become 1 by y minus 1, right? Or some constant by that, it doesn't matter. Some constant also you can take, because you can take that side, some constant will be coming. Okay, so dx comes as proportional to dy under root 1 by y minus 1, or here some constants may come. Okay, this equation in general form dx is equal to dy root under some constant, let us say c or c dash something, by y minus here some other constant, anything can be or 1 can be taken. This type of equation represents cycloid function. Cycloid. This is the differential equation of cycloid. Okay, which is called ODE, ordinary differential equation of cycloid. So this equation represents Brachistochrone curve. But better than that, I will also give mathematical parametric equation. So let me write parametric equation of cycloid. Cycloid is a curve where the point x and y are related like this. X is equal to a theta minus sine theta, where theta is a parameter, y is equal to a1 minus cos theta. This is a parametric form. Okay. Yes. Yes, sir. Yeah. Yeah, yeah. For J advanced it is. J means it is not there. For J advanced it is. Ordinary differential equation. Ordinary differential differential equation. Okay. So now, no, in class we will not cover it. Okay, that is this. In J advanced we will discuss it afterwards because these are also more complicated maths are there. Okay. So, but see right now what you need to know. So for that, coming back to this problem, in order to solve problem, of course you need this parametric form. This parametric form is important. Coming back to parametric form. Okay, this parametric form, actually I will explain what is meant by cycloid. Try to understand that. Suppose this is a circle. Suppose this is a circle and take this point P on this circle. Let us say that this circle rotates. So this circle will become, let us say, like this after some time. As this circle rotate, this point P, where it will go? Where it will go? I have to show it very close by. Okay. So let me show here exactly just below. I'm showing. Just after some time I'm showing. Okay, just after some time I'm showing. So as this is rolling, this point P which was at the top, after it roll, it might have gone somewhere here, right, like this. So again when you draw another circle, let us draw another circle after this, after some time. Yes, maybe overlap like this. This point might have gone next like this down. So you will find that this curve, this point on this circle is moving like this type of path. Okay, this path is the cycloid or Brachistochrone curve. Okay, that's what it is. So as a circle or a wheel rotates on the not rotate, it is revolving. Okay, just like the wheels on the of the car is turning on the road. So this point is going to move forward, and this trajectory in which this point moves, that trajectory is called Brachistochrone. But the more important thing is that we can write in this form. This you can try to derive it. Okay, now I gave you the idea how this equation can be derived. This you can try to derive. X is equal to a theta minus sine theta, y equal to a 1 minus. This can be derived. Definitely this can be derived. You can derive it. A can be taken as radius of circle, and you can try to find out how this equation is coming. Okay, this is possible to derive it. We'll see derivation in the next class afterward. But see, coming back to the question which we were seeing for that, you know, trajectory, this equation, that equation of this uh, curve. So in this curve, what you can see that this is the equation of a this equation. It is, let's say that this is 0 comma 0 origin, and this equation is what? Equation of inclined plane. It has to hit that inclined plane. So let us say this is inclined plane. It is hitting anywhere on this inclined plane. So you know this equation of inclined plane. Let us consider this as x-axis and this below as y-axis. Below as y-axis. So slope of this can be taken as this alpha, because this alpha is the angle of inclination, right? So we can write the equation of this line definitely. Can you write this equation of line? All of you know how to write this equation of line. Yes, because you know any point on this, you can take any point, because definitely we know this point below height is h. So along y-axis, this is x0, y is h. This point we know, and slope also we know. Slope is alpha. So let us write this equation: y minus y1 is equal to slope tan alpha into x minus x1. That means x minus 0. So y is equal to h plus x tan alpha is the equation of this inclined plane, right? That's the equation of inclined plane, and this equation of this is given by this, where a and theta are something which is we have to eliminate. A and theta is something which we have to, they are called parameters. So a and theta we have to eliminate. So this is the equation. This equation is x is equal to a theta minus sine theta, and y is equal to a 1 minus cos theta. Okay, so this point is 0 0 only. So if I substitute, because this point should pass through 0 0, so I can substitute here as 0, x is 0, y 0. So we may get some idea about a. Can we calculate a? We may not be able to leave that. Okay, it is passing through that definitely, because we do not know what is theta and a. Okay, leave it. Okay, but definitely at this point when it is hitting it, this is x and this is y. So because we know y is like this, that y we can equate from here. Here h is known, alpha is known, x is variable. So suppose if I substitute that x and y here, can we get some ideas from here? We can definitely get some idea here. Why? We can substitute as 1 minus cos theta is equal to h plus x. I will substitute as a theta minus sine theta into tan alpha. And then from here, maybe we will be able to calculate a, right? A we can calculate in terms of theta and alpha, and h we can bring it. Okay, but we want now, suppose this is the path we are choosing in this path, so we have to again apply the same approach at any point. Suppose it is here, so at this direction g will be acceleration will be g sine theta, and then you need to consider here velocity. Suppose it has followed a height of h, so velocity is going to be from here is equal to root under 2gh. And then acceleration you have to do, so some calculation is there, but there is one direct means idea related with that direct result I will give. That time, that is a remarkable property of cycloid. Note that. So time will be given as root under a by g into theta. So if you will be able to calculate a and theta, then you can calculate time from this. Okay, that you try. Okay, so the minimum time that we wanted to calculate can be calculated from this. If you can calculate a and theta, then we will be able to solve this. Okay, so right now I'm leaving it because it will become more complicated if you go into that. Okay, leave it. Clear? So this question, one question that we have discussed, has so many things in that, right? So now you try to understand this problem. Okay, take the question. A lot of depth will be there in such questions. Any doubts if you have, you can ask now. If I now I'm going to wind up, but I will take your doubts. Any doubts you have, you can ask. Yeah, yeah, you can please leave that. Okay, and then see the class. Okay, thank you. Yeah. Yes, Sam. Any doubts you have? No. So let us wind up this till here. Then we will see. And day after. Uh, Generally, it is not there, but if they ask some difficult type of first model that we discussed, that type of question was that type of question can where wire can be straight. Uh, this type will not be there because this is something which is completely out of so that may not be there. Fine, then we'll see next class. Okay. Yeah. Bye bye. Yes. Enjoy. Nissan. Okay. Yeah.